Hello all, welcome to the next lecture of the course. In this lecture, we shall see how to do transient analysis of a single stage compressor. So far, we have seen steady state analysis, that is time average or time independent problems. There will be no variation of boundary condition or any other parameter with respect to time. But in this transient analysis, the flow conditions will be varying with respect to time, or it will be time dependent. Now we shall check the details of transient analysis. Transient blade row models are used for transient analysis in Ansys CFX. We shall now look at the basics of transient blade row models. Transient blade row models are categorized into profile transformation, time transformation, and Fourier transformation methods. We shall discuss profile transformation and time transformation models in this tutorial. Profile transformation model. This model is mainly used for transient rotor stator frame change analysis, that is between a moving rotor and a stationary stator component. Profile transformation results in same solution as conventional transient simulation with transient rotor stator interface. We have to specify this transient or steady state analysis in the analysis type option. I will explain about the transient and transient blade row models shortly. In profile transformation, the flow profile of the upstream domain outlet shall be scaled and given as input into the downstream domain inlet phase. Hence, it is important to have pitch ratio close to 1 between both the domains, that is between rotor and stator domains. So, in profile transformation, we may need to model multiple domains to meet the pitch ratio close to 1. For example, in this case, there is a single stage rotor and stator. The number of blades of rotor are 36 and stator are 46. So the sector angle is given by 360 degrees by number of blades, that is 10 degree for rotor and 7.82 degrees for stator. So we can calculate the pitch ratio based on this angle, that is 10 by 7.2, which is close to 1.27. So to make this pitch ratio close to 1, we have to multiply the number of rotors and stator domains. In this figure, we can see we have created 3 rotor domains and 4 stator domains. So the sector angle now becomes 30 degrees for rotors and 31.28 degrees for stators. The pitch ratio is now close to 1, that is 30 degree divided by 31.28, which is close to 1. Next is time transformation model. This model is mainly used for transient rotor stator frame change analysis, and it is valid only for compressible flows. This model can also be used for transient inlet disturbance cases. The advantage of time transformation model is we can use single sector periodic domain for both rotor and stator. The pitch ratio should be close to 1. In this method, the pitch ratio should fall within a certain range, that is given by this expression. Here, m omega represents the Mach number associated with the rotor rotational speed, m theta is the Mach number associated with the tangential flow velocity, and Ps by Pr refers to the ratio of stator domain pitch to rotor domain pitch. For most applications, m omega is in the range of 0.3 to 0.6, and the ratio of Ps to Pr will fall between 0.6 to 1.5. Hence, time transformation model allows you to solve problems with single rotor and stator periodic mesh which has the pitch ratio in the range of 0.6 to 1.5. For more details on time transformation method, you can refer Ansys help manual. Now we shall look at the example problems of profile transformation and time transformation.